All right, so for this problem, let f be the function given by f of x equals that. For what positive values of a is f continuous for all real numbers x? Well, it seems like, if you give this some thought, this is kind of a pre-calc question. It's kind of weird that it's on this exam. But in order for it to be continuous, it can't have any asymptotes. And so this is a rational function that we're looking at here. And if this is ever 0, we're in bad shape. So, of course, if a is negative, then this would be x squared plus some positive integer, and then we'd be okay. This would be defined everywhere. That's all good. But if a is positive, then we're in bad shape. They're trying to trick you here into thinking that, oh, if this a were 4. Like if you had a 4 there, then these would just cancel out. Well, the problem then is you then have holes at both 2 and -2. So, and any of these other ones will give you, a hole somewhere or asymptote somewhere. So the answer is A, none. All right, this is a nice little question that is asking you to find the second derivative of this function that's given, this differential equation that's given. You're given the first derivative, and you have to find the second derivative. And it's the second derivative with respect to x. So I need to take the derivative of this with respect to x. And so, d dx of dy dx, and that's going to equal d dx of this square root of 1 minus y squared, which is the same thing as d dx of 1 minus y squared to the, that is illegible, to the 1/2. So what's that going to be? Well, it's going to be 1/2 the quantity 1 minus y squared to the negative 1/2, but then times, you got to take the derivative of the inside, and the derivative of the inside is going to be 2 times y times dy dx. And so we can clean this up a little bit. These 2's can cancel. The other thing that can happen, well, you can put this, you can write this as 1 over the square root of 1 minus y squared times, well, there's there's a negative right here. So it's be times, and this would be negative y. And then times dy dx, and dy dx, well, that's this thing that was given to us. That's going to be the square root of 1 minus y squared. So nicely, these cancel out, and now I'm left with negative y as the answer. So the second derivative is B. So that is some chain rule stuff going on, but also the fact that you have to keep in mind that you're differentiating with respect to x. So that adds an extra little piece of challenge because otherwise you'll get this answer right here. So I bet the people that got this wrong, many of them probably got choice C because they forgot to multiply by this dy dx, which you need to because you're differentiating with respect to x. All right, so this one here, you're given f of x is defined as g of x plus 7, and from 3 to 5, and then you're asked to find this integral here and write this in some other way. Well, we can do a little substitution here. So we have from 3 to 5 of f of x. Well, the f of x is g of x plus 7, and then plus g of x, and then it's dx. So that will simplify to 2g of x plus 7 dx, and that's from 3 to 5. And then what we can do is break this up into 2 different integrals, one of them being the integral from 3 to 5 of 2g of x dx, and the other one's going to be the integral from 3 to 5 of 7 dx. And that's going to become, that one we can actually do. This one we have to leave here, and you notice that's showing up in a lot of places here. So, so those are bad. These are no good because there's no 2 there. So the question is which of those? Well, we can actually, the second one here, this guy here, we can actually do. This can become 7x evaluated from 3 to 5, so it's going to be 35 minus 21 which it's hard to read, but that is going to be 14. All right, so it's going to be plus 14, which is this guy here. So it is choice B. 82 is choice B. All right, so 83 is a tricky problem, and I'm not sure I like this problem too much because I think it's a bit misleading. But you're given a Taylor series for the natural log of x, centered at x equals 1, and it's right there. So they derive that for you. You could derive that if you wanted to, but there we go. So let f be the function given by the sum of the first three non-zero terms of this series. Okay, great. So f is defined as the first three non-zero terms of that series. So f is going to be an approximation for the natural log of x, and it's going to be approximation about x equals 1, centered at x equals 1, kind of tangent at x equals 1, if you will. So they want to know the maximum value of this. Now, normally I would think the difference of natural log of x and f of x as the error. And so the natural place that I would go is I'd be thinking about the next term. I'd be realizing that this is an alternating series, because if I start writing out the terms of this series, the first term is, so f of x is going to equal, well, the first term is x minus 1, and the second term is going to be minus x minus 1 squared over 2, and it's going to be plus x minus 1 cubed over 3. And they want us to find this. And I would be like, oh, well, this is an alternating series. So the next term is going to be x minus 1 to the fourth over 4. Now, the thing is, it's not always an alternating series. That's the tricky part here. It's an alternating series if, and only if, x is greater than 1. Because if x is greater than 1, then these arguments here, this, and this are all positive, so this thing will alternate. Wonderful. However, if x is less than 1, then this will actually be negative, this is going to be negative, and this is going to be negative. So they are all a negative, so it's not alternating. So that won't work. What else can you do here? Well, so this method here of looking at the next term is not going to work. We could try to go the Lagrange m times x minus 1 to the fourth over 4 factorial and think about that. However, this is a calculator section, and we actually can graph this function, and we can graph that function that's defined right here, and then we can actually take the absolute value of it and look at how big that thing gets on that interval. Okay, so here's a little video I made walking you through that. All right, so what you have to do is you have to enter in the function. We can enter in natural log of x, and we can also enter in the function, that series, the first three terms. So it's going to be x minus 1 minus x minus 1 squared over 2, and then plus x minus 1 cubed over 3. And there's that. And what we care about is the difference between these two functions on the interval from 0.3 to 1.7. So what we can do is graph another function. We can make this the absolute value of f1 of x minus f2 of x. Alternatively, you can just type these all into the absolute value. You do have to be careful because you're subtracting that series, so you have to watch your signs. But since it's an absolute value, it doesn't matter if it's f1 minus f2 or f2 minus f1. So you can switch those around, so that actually can be helpful. And there's the difference. And so what we care about is the maximum value of this difference, the absolute value of this difference, on the interval from 0.3 to 1.7. So we can do that a couple ways, but I'll just go Menu, Analyze Graph, Maximum, which function? I want this guy. What's the lower bound? Well, I can type in 0.3, and the upper bound I can type in 1.7. If I do that, there I go. And I can see that the maximum is there at 0.145, which is one of my choices. Perfect. There we go. All right, when does this series converge? Well, this is screaming at me, at least it's screaming at me. It may not be screaming at you, but this is saying ratio test. That's one of the great ways to figure out intervals of convergence. It's definitely the best way. So let's do it. Do a little ratio test on this, and we'll have x plus 2 to the n plus 1 over square root of n plus 1 times the square root of n over x plus 2 to the n. And we look at the absolute value of that, and when is that less than 1? Because what I just did was a sub n plus 1 over a sub n, the absolute value of that, and looking at the limit, important, the limit as n goes to infinity. Well, this simplifies a little bit. This will cancel out, so I'm left with just this here. And as n goes to infinity, these two parts here are going to basically become 1. We're going to have the absolute value of x plus 2 being less than 1, which tells me that x plus 2 must be between negative 1 and 1, which then if I subtract 2, I get negative 3 is less than x is less than negative 1. All right, so that narrows it down to A, B, or C. That gets rid of these guys. They're gone. So then the question is whether it converges or not at the endpoints. So we got to check those endpoints. And if we check negative 3, well, I'll check negative 1 first. If I check negative 1, this series turns into the sum from n equals 1 to infinity of 1 over root n. And by the p-series test, p in this case is a half, this is divergent, so it cannot equal negative 1. So this is no longer an option. All right, so now we're down to a and b. If we plug in negative 3, this turns into the sum from n equals 1 to infinity of negative 1 to the n over root n. And this is now the same series, but it's alternating. And it's alternating. The terms are going to 0, and they're getting less each time. So yes, negative 3 does work. Therefore, it is choice B. 84 is B. So don't forget to check the endpoints. That's the big mistake that people make and lose points because of it. So anyway, hope that helps. All right. So so you're given this is a 3D volume, but there's some solid, and the base of it is in the first quadrant, bounded by the two axes and the line x plus 2y equals 8. So if cross sections to this solid are perpendicular to the x-axis are semicircles, what's the volume of the solid? Now you got to make sure that you're slicing this thing the right way, and they're saying that it's semicircles if they're perpendicular to the x-axis. All right, so often on these problems people misread this, and sometimes they'll say parallel to the x-axis and perpendicular. Just pause for a minute and make sure that you get this one right. So it's so often that people slice it the wrong way. So they're saying perpendicular to the x-axis, so that's going to be this way, perpendicular this way, and those are going to be semicircles, so little semicircles like this. So what is the radius of each semicircle? Because if we slice this up, we're going to have a little kind of half of cylinders. And so the cross section like that is going to be a semicircle. So we want to know the radius of that, and the radius is going to be half of the y value. So that's a radius. That's the radius of that. So so what is the area going to be? Well, it's going to be 1/2 the radius squared, but then times a half times pi. So that is a semicircle. So this half here is because that total height is y, and we want half of that. But then we want a semicircle, so we need that 1/2. So this is the area, and then how thick is each slice? Well, it's a little dx thickness, and then we want to sum that up from 0 to 8. Now, the problem now is that we have to integrate with respect to x, so we need to know what y is. Well, luckily, we've got this equation here, which tells us that 2y equals 8 minus x, so y is equal to 4 minus half of x. So when we put this all together, we'll have the integral from 0 to 8. Well, we can pull out a 1/2 pi out of the whole damn thing. Actually, we can take out a 1/8 pi, because we got this 1/2 squared, we got that 1/2, so we get 1/8 pi, and then we're left with y squared, and that's going to be 4 minus a half of x squared dx, and then we crank this in our calculator. We could do it by hand, but that is a waste of time. And if we crank that in our calculator, we should get 16.75 as the answer. There you go. All right, this is an interesting little variation on problems that you've seen before. Yeah, because they could just ask you, often they'll just say, okay, what is this equal to? But that's not what they're asking. They're asking, when does this graph, which is an infinite series, when does that intersect this? And I guess you could graph a whole bunch of terms of this, and then see where it intersects. That's one thing. Or you could realize that this is a series that you should know, or close to a series that you should know. That it kind of looks like the sum of x to the n over n factorial, which is e to the x. However, it's alternating, and the way to get it to alternate is you replace x with negative x. So this series here is actually y equals e to the negative x. So so if you were to graph these, you got e to the negative x, which is going to look like this, and you got y equals x cubed, which is something like this, and they are going to intersect somewhere at some x value. And if you graph those both, then you'll see that the point where they intersect is at the x value is 0.773. So a nice little variation. Make sure you use your calculator a bit, but also the key thing that can really help you here is knowing what this function, what that is. That represents e to the negative x. All right? All right, so this is a problem that's getting close to the end of the test. You're getting tired, and actually it's not. This is the end of the multiple choice part. You still have the free response to do, but you would, it's easy to fall into the trap here, and not really read what the question's asking. So they're saying a particle starts from rest at the point 2, 0, and then if you gravitate right towards these two choices, then that's not good because you have to read what these axes and these graphs stand for. Don't just see 2, 0 and think, oh yeah, this is where to go. The particle moves along the x-axis with a constant positive acceleration. Which of the following could be a graph of the distance of the particle from the origin as a function of time? So this is distance from the origin versus time, and it starts at 2 away from the origin. So these are the ones we want to do, or possibly this one. But then it says it has a constant positive acceleration. So if the acceleration, all right, is positive, and it's so if the acceleration is positive, so we could say, okay, well, x double prime of t is equal to some constant. Well, that tells us that the velocity, which is the first derivative, is going to be linear. And it tells us that the original, and there, I guess there could be some other C2. And it tells me that the position is going to be then a quadratic plus C2t plus, C3. But this is a quadratic. So it's going to be initially 2 away, and then it's getting further away from the origin as time goes along, and it's a function of time. We don't know if it's positive or negative acceleration, but however, it's going to be a quadratic moving away, and that's only one choice because this is just constant position. This is actually a constant velocity, and then so this is our choice. 90 is A. All right. So I hope all these videos help, and these all made some sense. If not, let me know. Thanks.